In this lesson, we're going to be talking about how to simplify expressions with radicals. We're going to be adding them, subtracting them, and multiplying them. So whenever we are summing square roots, whenever we're adding, there's a rule. In order to add square roots, the radicands have to be the same. Now, I talked briefly about radicands last lesson, but if I look at this problem, the radicand is the number that is under the square root sign or the radical sign. So on this first one, I have 3 square roots of 2 plus 4 square roots of 2. So I'm going to look at that radicand, the number under the square root sign, and it is the square root of 2 on both of these. So the square root of 2 and the square root of 2, they are both the same. Those are my radicands. Are the same, so we're good there. So that means that we can add them, and when we do that, if you look at your answer, the radicand, that number that was the same, stays under the radical, and then all I have to do is take the number on the outside of the radical and add it. So 3 plus 4 gives me this 7 square roots of 2. So the radicands have to be the same to add. If they are the same, that just comes over into our answer, and then we add what's on the outside. So if I'm going to subtract or take the difference of the square roots, it's the same concept. In order to subtract, my radicands still have to be the same. So if I look at this problem, 30 square roots of 5 minus 4 square roots of 5, my radicands are square root of 5. So my radicands are the same. Which means I can subtract. That square root of 5 comes over here into my answer. And then all I do is take the outside number part, the 30 and the 4, and I'm going to subtract 30 minus 4, and that gives me the 26. So 26 square roots of 5. Now, whenever I'm finding the product or I'm multiplying, I do not have to have the same radicand. Okay? The rule for multiplying is I'm going to multiply the radicand with the other radicand, which means the number inside the radical times the other number inside the radical. And then I'm going to multiply the outside numbers times each other. So really quick, let's label this. The 2 is the outside. The square root of 3 is my radicand. The 6 is my outside. The square root of 7 is my radicand. But again, with the product, these numbers do not, these radicands do not have to be the same. So I'm going to multiply my outside numbers. 2 times 6, that gives me this 12 over here. And then I'm going to multiply my radicands. Square root of 3 and the square root of 7 gives me the square root of 21. Okay, now I do have to be careful when I'm doing these. Once I multiply, can I simplify the square root of 21? Is there a perfect square that divides into it? And remember, I'm going to write them down over here. Those perfect squares that we talked about. Remember, 2 squared gives me 4 is a perfect square. 3 squared is 9 is a perfect square. 4 squared, 16 is a perfect square. 5 squared, 25 is a perfect square. 6 squared, 36 is a perfect square. 7 squared, 49 is perfect. 8 squared, 64 is perfect. 9 squared, 81 is perfect. 10 squared, 100 is perfect. So all of these right here are our perfect squares. So these are what we're looking for to divide in. to simplify. So will any of these numbers divide into 21? No, they won't. So we cannot simplify it. Okay, let's look at the steps now. What do I need to do if I'm adding or subtracting? First thing I'm going to look at is to see, do I have the same radicand? If I do have the same radicand, then I just add or subtract the outside numbers and keep that radicand. Now, what if my radicands aren't the same? That means I'm going to try and see, can I simplify one or both of them by using these perfect squares that I just wrote down. If I can simplify one of them down, then I may be able to have the same radicand. We're going to look at some of these examples in just a second. And then, if I do get to the same radicand, I can add and subtract the outside numbers. And then remember, if I'm adding and subtracting, my radicand stays the same. It does not add or subtract. It doesn't change. Now multiplying, I'm going to multiply the numbers together, the outside numbers together, and then the inside numbers together. Then, at the end, if possible, I'm going to simplify it down by using these perfect squares we just wrote over to the side. So let's look at some examples together. Example 1, 14 square roots of 2 plus 3 square roots of 18. I'm adding, which means that I have to have the same radicand. So if I look, unfortunately right now my radicands are 2 and 18. So I don't have the same radicand, but can the radicands be simplified, one or both? Yes. Which one can be simplified? The square root of 18 can be simplified. Square root of 2 is down as low as it can go. So let's simplify the square root of 18. We talked about that yesterday in the notes. So the square root of 18, so if I go back to these numbers that I have listed here on the side in red and blocked off in green, I need one of these numbers that will divide into 18. Okay, 4 won't. 9 will divide into 18. So my perfect square is 9 times 2. So that square root of 9 is my perfect square. Square root of 9 gives me what times itself is 9? 3 times 3. And then the square root of 2 is going to stay under the radical. Now, since I simplified that, can we add or subtract? Yes, we can now add. Why? Because my radicands are the same. Okay, so let's actually add this thing. So my first number was 14 square roots of 2. That did not change. Plus that 3 square roots of 18 changed to, oh, and let me go back. I made a big mistake. This was 3 square roots of 2. I forgot this 3 out here. So this 3 and this 3 is going to give me 9 square roots of 2. Because I do have to multiply those outside numbers. Now I can, again, multiply these. My radicands, square root of 2, square root of 2, that's the same. So since they're the same, all I'm going to do is take my outside numbers and I'm going to add them. 14 plus 9 gives me 23 square roots of 2. And that is my answer. Okay, let's look at the next one. 6 square roots of 125 minus 7 square roots of 80 plus 2 square roots of 14. So right now I cannot add or subtract any of these together because none of them have the same radicand. But can I simplify some radicands? Yes, I sure can. If so, which ones? I can simplify the square root of 125, and I believe I can simplify the square root of 80. I don't think that I can simplify square root of 14. So let's do the 125 first. So I'm going to come back over here into my list. I need a number, 4, 9, 16, 25, 36, 49, 64, so forth, that will divide into 125. I believe 25 will go into it. If I'm thinking about quarters here, how many quarters give me $1.25? 5 of them do. So I'm going to take my perfect square, 25. What's the square root of 25? 5. 5 times 5 gives me 25. And then I'm going to bring over my non-perfect, 5 square roots of 5. Now, I do have to be very careful when I'm going back, because on the outside of this thing, I had a 6. And so I'm going to need to multiply that 6 and that 5. And I'm going to come down here. 6 times 5 gives me 30 square roots of 5. So that's this first part. That's done. Okay, now I'm going to do the square root of 80. So I'm going to come back over here. I need one of these numbers from this list that goes into 80. 4 does, but I don't think it's the biggest number. So keep going through and find a bigger number that will divide into 80. I think 16 will. And if you need to take a calculator out, take it out. 16 times 5. So the square root of 16 is 4 square roots of 5. And I do have to be very careful here. There was a 7 on the outside. It needs to multiply by that 4. 7 times 4 gives me 28. So I'm going to do minus 28 square roots of 5. And finish my problem, plus 2 square roots of 14. And again, will any of these numbers in this list here, 4, 9, 16, 25, and so forth, divide into 14? No. So it cannot be simplified. So I can add and subtract some of this, not all of it. I can subtract these first two because they have the same radicand. So my radicand is going to stay the square root of 5. And then I'm just going to subtract the outside numbers. 30 minus 28 gives me 2 plus, now I cannot add this 2 square roots of 14 because 14 and 5 are not the same thing, same radicands. So this 2 square roots of 14 just comes straight down into my answer. And so this is my answer, 2 square roots of 5 plus 2 square roots of 14. That's as far down as I can go. Okay, example 2 is looking at multiplying these radicals together. So when I'm multiplying, remember, you do not have to have like radicands when we're multiplying. Okay, so 4 square roots of 10 times 12 square roots of 18. We can do this. What are the numbers on the outside of the radical? My outside numbers here are 4 and 12. So we can multiply these together. 4 times 12 is going to give me 48. And then my radicands, the square root of 10 and the square root of 18, I can multiply those together. And I'm going to get the square root of 180. So can we simplify the square root of 180? I'm pretty sure we can. So we're going to have 48 square roots of 180. So I'm going to come back over here and I'm going to find one of these numbers that will go into 180. I believe 36 will. I think 36 times 5 is 180. So the square root of 36 and the square root of 5. So the square root of 36 is 6 square roots of 5. That comes down. Now, I got to be very careful when I'm getting my answer, because I got to take this 6 and multiply it by this 48. Don't forget that part. So I'm going to do 48 times 6, 8, 4, 288. So my answer is going to be 288 square roots of 5. Okay, the next example. 15 square roots of 3 times 2 square roots of 6. So my numbers on the outside are 15 and 2. So I'm going to multiply those. 15 times 2 gives me 30. My radicands are the square root of 3 and the square root of 6. Since I'm multiplying, I can multiply those. Square root of 3 times the square root of 6 will give me the square root of 18. Can the square root of 18 be simplified? It sure can. So I'm going to have 30 square roots of 18. I'm going to simplify that down. So I'm going to come back over here, find a number that will divide into 18. 9 will. Square root of 9, square root of 2. Square root of 9 is 3 square roots of 2. I got to be very careful. I got to multiply the 30 on the outside with the 3 on the outside. And 30 times 3, that's going to give me 90 square roots of 2. Okay, so you have 4 for your daily practice today. So go ahead and fill these out. If you need to do them on another sheet of paper, that's perfectly fine. Take a picture of them and then upload them to Google Classroom for me. And then you also have some iExcels to finish.